Okay, so here we are. We are calibrating an alcohol thermometer today. This is our thermometer. It contains a blue dyed alcohol within the actual channel within this glass tube. And the level of that alcohol will change depending upon the temperature of the liquid that you place into it, or you place it into, rather. On the sides you have your degrees Celsius. So this is our temperature scale that's been marked onto this, printed on top of that glass tube. Now, an instrument is as good as its manufacturer and is as good as the person who is actually taking the measurement with it. So today, what we're going to do is basically test how well calibrated these markings are and that column of alcohol. And to do that, we're going to measure two well-known standard temperatures. So the two temperatures that we're going to be looking at are the freezing point of water, which should be 0 degrees Celsius. That's what we should read on our thermometer when we put this into freezing water. And we're also going to look at the boiling point of water. Okay, so we're going to set this up. We're following our experiment for calibrating a thermometer. And I have here a 150 milliliter beaker that has some ice in it. I'm just going to add a little bit of water so that we actually have something we can immerse the thermometer into, the bulb, and measure the temperature. We're going to allow probably about 15 minutes or so. So this is distilled water that I'm adding into the beaker. See, that's probably, give it a little bit more. That's probably about enough. Okay, so this is distilled water. You can see that we're putting into our beaker. We're going to just let that chill out for a little bit and let the water come to the same temperature as the ice. Into our second 250 milliliter beaker, we are going to add some water to boil. So I'm going to fill this about halfway, and I'm getting tired of squeezing it out, so we're just going to pour. Okay, and now we're going to take this beaker of water, again, distilled water, so there's nothing, no contaminants in there, it should be just pure water, and we're going to heat it up on our hot plate. So I'm just going to turn this on and get it going. And we're going to really max out that temperature so that we get it boiling quickly. Okay, so it's been about 15 minutes. We can see that my water started to boil, and I also have my ice water here. It should be at the same temperature as the actual ice. So what I'm going to do is actually take the measurements for both of these right now. So when I'm reading my thermometer, I want to get down on eye level as close as I can. Look at the level of that alcohol, the blue liquid in the thermometer itself. And I realize I can't get the camera quite close enough for you guys to see this. But on this particular thermometer, the smallest markings are to the 1 degree place. Okay, it goes from 0 to about 110 here, and actually it goes from -20 to 110, and each of those tiny little markings are to the 1 place, which means that I can estimate 1 place past that when I report my temperature. And as I'm looking at this blue level of the liquid, it looks like it's falling right on the 1 degree Celsius marking. So when I record this on my data sheet right here, I'm going to put my measured temperature for freezing point of water as 1.0 degrees Celsius. And that's recording with the appropriate significant figures, making sure that I've estimated 1 place past the smallest line that I can read on that thermometer. Okay, so I'll show you this thermometer the temperature is going to be rising, but hopefully you can actually see the markings on there to actually see that these are, the smallest markings actually stand for 1 degree. So we just estimate 1 place past, which is to the 10th place, 1 place past the decimal. Okay, next we're going to take this boiling temperature measurement. So I'm going to hold this. Now you want to be careful when you take the measurement of any heating liquid that you don't actually touch the bulb of the thermometer down to the bottom of the beaker or the glass container, because then you're actually measuring the temperature of the plate, the heating element, or at least the top of that. And you really want the temperature of just that liquid. And so this is actually, my alcohol level has risen very quickly, and it's still rising here. So I'm still waiting for it to kind of level out. All right, we're going over the 100 mark actually on this. This is not necessarily that well calibrated, but we'll see. It turns out that boiling point also depends upon the atmospheric pressure. Freezing point is pretty standard, regardless of the atmospheric pressure, under normal conditions of about 0 degrees Celsius. But boiling point can actually vary a little bit. We usually just say the boiling point of water is 100 degrees Celsius, but it can vary depending upon the pressure. And right now, we're still going just up a little bit. Oh my, it's going up. Okay, I think it's leveled out a little bit. It seems to have stopped in between 102 and 103, those two markings. So to me it looks a little bit closer to 102. So I'm going to estimate that that's about 102.3. That's my measured temperature of the water, of the boiling point of water, with my particular thermometer. Okay. So this 102.3 degrees Celsius. Okay, we can turn off our hot plate now. Now, in order to calibrate our thermometer, we do have to fill in the expected temperature as well. So that's our comparison point. So next, we're going to look at some of the expected temperatures. Okay, so let's fill in the rest of our data table here. We've got our measured temperatures over on the right-hand side. We know that our expected temperature for the freezing point of water is 0.0 degrees Celsius. Okay? Now the boiling point of water is going to vary with the atmospheric pressure. So on your instruction sheet, I actually do have a equation that you can use to take the atmospheric pressure that's been measured and relate that ultimately to the actual boiling point, your expected boiling point of water. It may be more than, it may be less than 100 degrees Celsius, depending upon that atmospheric pressure. So today I looked up on a weather website what the measured atmospheric pressure was, as close to the time of measurement as I could figure out, based in Haverhill, which is where I am recording this video this morning. Okay, so we are dealing with 30.26 inches of mercury. That's straight from the website. That's the measurement it gave me. Now, my particular equation that I'm going to be using, it's actually the true boiling point of water. This is going to be our expected boiling point, is going to be equal to 100 minus a conversion factor. It's about 0.037 degrees Celsius per millimeter mercury difference from standard atmospheric pressure. And standard atmospheric pressure is 760 millimeters of mercury. So we're going to deal with minus 0.037 degrees Celsius per millimeter of mercury times 760 millimeters of mercury minus our atmospheric pressure. Okay? Now, the issue here, though, is that our atmospheric pressure reading was actually in inches of mercury, and we need to subtract it from millimeters of mercury. So we have to convert inches to millimeters. Okay, that's not a big deal. This is just in inches to millimeters conversion factor. And so I looked up, but you can also figure this out yourself. 1 inch is equal to 25.4 millimeters. Now the mercury is just going to stay in there in terms of the pressure unit. So we'll be converting the inches and the millimeters, but the mercury is going to stay as is. So we're just going to set this up as a simple conversion. We've got 30.26 inches of mercury as my starting point, my given. I'm going to set this up so that the unit that I want to cancel out, which is inches, is on the bottom. So we're going to put inches on the bottom. And the unit that I want to get, which is millimeters, I want on the top. Okay? I always do my units first, because then it tells me which number goes on top and which goes on bottom. And I'm always setting it up so that the units that I'm given are canceling out. And the other half has to go on top, okay? And in this case, the other half, I've got one conversion that will lead me directly to what I want, which is millimeters. Okay? And so this is going to leave me with millimeters. It's actually going to be millimeters of mercury because we're not changing that mercury. Now I can just substitute in the numbers that are attached to each of those units for my conversion factor. So I've got 1 for the inch and 25.4 for the millimeters. All right, so here's my calculation. It's 30.26 times 25.4 divided by 1. That's not actually going to change anything. I'm just going to enter that into my calculator here. And that is going to give me 768.6. Okay, now I can carry this into my calculation down below here. And I can substitute in, I'm going to have 100 minus at 0.037 degrees Celsius per millimeter of mercury. And that will be times the difference between 760 and 768.6. So 760. And 760, this is a defined value for atmospheric pressure, so we can assume infinite significant figures here. I'm going to add a few just to show. Right? I've got one decimal place here, so I'm just going to carry that one decimal place just to show that this number is not going to limit our significant figures in the end in any way. Okay, and this is going to be equal, or excuse me, minus 768.6, and both of these are millimeters of mercury. Now 760 minus 760.68.6 is going to give me negative 8.6 millimeters of mercury. We're going to multiply that by our 7.037 degrees Celsius per millimeter of mercury. And whatever we get for that difference, we're going to subtract from 100 degrees Celsius. Okay, so again, I'm going to do a little calculation here. I'm going to take my 8.6 multiply it by 0.037. Okay, that's going to give me a negative 0.32 value. So this is going to be minus a negative, because I have that negative 8.6 there, 0.32 value. And that's in degrees Celsius. My millimeters of mercury completely cancel out when I do that multiplication. So it's just in degrees Celsius. And then we've got that subtracted from 100. Well, 100 minus a negative, right? These two are going to turn this into a positive. It's actually going to add. And we're going to end up with 100.32 degrees Celsius. Okay, so that's as precise as we can get it. This 100 does, the way it's displayed right now, does have one decimal place. So I guess we could technically reduce that to 100.3. And that should be fine as a comparison point, because our actual measurement was only to one decimal place. So 102.3 versus 100.3. Okay, so that's what we're going to carry over and put into my expected temperature for the boiling point of water. So the last measurement of temperature that we want to make is actually for one that we don't know the correct or true value for. We just want to take a measurement of room temperature water and use our calibration curve for our thermometer that we created from our standard temperatures and figure out what the true temperature of water should be for this thermometer. So even if your instrument, your measuring device, in this case our thermometer, is not calibrated well in terms of your particular reading, you can actually correct for that using a calibration curve. And that's what we're going to do. We're going to calculate the corrected room temperature, the true room temperature that we can measure using this poorly calibrated thermometer. Okay, so here we go. This is distilled water again. We're just going to add it to a small beaker here, about 40 mils of that. The exact volume doesn't matter, right? We just want to get enough in there that we can submerge our thermometer. So now I'm going to put the thermometer, making sure the bulb is in the liquid, and allow the temperature to adjust. Okay, it's a little chilly this morning, and I'm reading, I'm getting down as close to eye level as I can and waiting for, it looks like that thermometer, the liquid level, I think it's just about level now. It doesn't seem to really be changing all that much. So we're going to go ahead with that reading, and it looks to me like it is right on the 11 line. So that means my last temperature is going to be 11 degrees Celsius. So we'll record our measured room temperature here for room temperature water. It looked like it was right on the 11 degree line, so I'm going to estimate one place past that, which is 11.0 degrees Celsius.